We're talking about solving exponential logarithmic equations, and we want to solve logarithmic equations. And one of the ways that we can do that is we can use the property of equality of logarithmic equations. So basically it says if you have the log base b is equal to x and the log base b is equal to y, if and only if x is equal to y. So basically it says if you have the log on one side and the log on the other side of the same base, then what you're taking the log of has to be equal. So in this case, we're looking at example A. We have the natural log and the natural log. So if they're both the same, then we can just set what we're taking the natural log of equal to each other. So 7x minus 4 is equal to 2x plus 11. And then we can just solve it. We can add 4 to both sides. And 7x is equal to 2x plus 15. Then we can subtract 2x. And then we get 5x is equal to 15. And then we can divide by 5. So x is equal to 3. Now, whenever we have the log equations, we have to remember to check the domain, because generally the log function does not include all real numbers. So we have to check to see if this will actually work in the given equation. So we decided that x is equal to 3, and we have the function natural log of 7, and then we figured out that x was 3, natural log of 2, and so we want to check this. So we get the natural log of 21 minus 4 is equal to the natural log of 6 plus 11. So natural log of 17 is equal to the natural log of 17. So this one does work. So x equals 3 is a solution there. We can go back and look at example B. In this case, we're talking about the difference between these two. Over here in example A, we had the natural log and the natural log on both sides. Over here, we just have log base 2 on this side, and we don't have anything on the other side. So we're looking at this example. This is how we'd solve this one. If you don't have a logarithmic function on both sides, then you can exponentiate each side to help you solve the equation. And so that's what we want to do. We want to exponentiate each side. And what we will say is we want to pick exactly how we want to do it. So this is log base 2. And we want to pick the base here, because that will help us out by eliminating the log later. So we want to say 2, and then this is the exponentiate, where we raise what was there and we put it in the exponent. 2 log base 2 of x minus 6, and that is equal to 2 to the 5th. And now 2 log base 2, that is going to be equal to 1. And so we can take our exponent here, part of the exponent here, we can move this out in front. And so we get x minus 6 is equal to 2 to the 5th. And then we can, we know what 2 to the 5th is. 2 to the 5th is 32. And then we can add 6. And then we get x is equal to 38. But then we want to check to make sure that this will work. So we take log base 2 minus 6 is equal to 5. And so we're going to substitute 38 in. Log base 2 of 32 is equal to 5. And that is true. We can rewrite this. 2 to the 5th power is equal to 32. So that is true.